All right, so let's take a look at this dot plot. Although it looks like a histogram, it is a dot plot. Each of these blocks represents one data value. So you can see that we have 1, 1, 2, 2s, 3, 3s, and so on until we have 1, 7. We can see the data over here to make sure that we're right. Now, what do you notice about the shape of the graph? You're right, it's symmetric. We can see that the left and the right sides, if you fold over in half along this vertical axis, would be symmetric. We call the shape of this graph symmetrical. All right, look at the mean and the median and the mode. What do you notice about the mean, the median, and the mode for this graph? The mean is 4, the median is 4, and the mode is 4. They are all the same. That's another definition of a symmetric data set, that the mean is equal to the median, which is equal to the mode. Now, what happens if I put a value over here to the left? What do you think is going to happen? Do you think the mean, the median, or the mode will change? All right, let's check it out. Let's add a -3. What do you notice about the graph? Most of the data is still over here near the 4. But now this -3 is pulling down the data. Notice, did the mean or the median change? The mean did. The mean is now smaller than the median. We call that skewed left, because this value over here on the left is pulling the mean down. Most of the data is still to the right, but again, we call that skewed left. All right, let's remove the -3. Let's go back to our symmetric graph. Notice that the mean and the median are equal again. And let's add a data value to the right, a larger value. Let's actually do 10, do 2, 10 and 11. All right, let's look what happened to the graph. Most of the data is still over here in the middle, close to 4. But now we have 2 values to the right, which has changed the mean. The mean is now bigger than the median. Again, most of the data values are over here, but these 2 larger values are stretching the mean to the right. We call that skewed right. So you can see it on a graph. It's skewed right, and the mean is larger than the median. All right, so today we're looking at interpret differences in shape, center, and spread in the context of the data sets, accounting for possible effects of extreme data points or outliers. So we're looking at the shape, the center, and the spread. All right, so let's review. Skewed left, which is also called negative, is that the mean is less than the median. You can also think that the median is larger, but I like to always start my statements with mean so I don't get confused. So the mean is smaller than the median if it is skewed left. We know that it's symmetric, that the mean and the median are equal. Okay, so again, that makes sense that they're equal, that the data is really balanced. Okay, and then if it's skewed right, we know that that mean is being pulled to the right, so the mean is greater than the median. So if you have a set of data and you have the mean and the median, you can go ahead and decide which way it's skewed. All right, we can see here are 3 graphs to just kind of show us the shape of that. So let's see. Highlighter, if we try and kind of draw it, I always think if I'm going up the slide, I go up the ladder and then swoosh down the slide. That reminds me that that's skewed left or slanted to the left. Same thing with skewed right. And again, because I'm a mom, my kids would go up the ladder and then they would slide to the right. And then of course symmetrical, the mean and the median and the mode are equal. So it doesn't matter which side. Now on a box and whisker plot, you're going to see that by where the tail is. So we're going to have a longer tail if it's skewed left because most of the data is going to be on the right, and that outlier or value over there on the left is skewing or pulling the data to the left. A symmetrical graph is going to be what you think. It's the same on both sides. And then skewed right, again, we're going to have our tail on the right because that one value or those few small values are pulling most of the data, which is to the left. It's pulling that to the right. So you're going to have a long tail to the right. All right, here's a dot plot. Now, again, it's not going to be perfect. If I look, this one set of zeros is kind of messing up our data completely, but it still is skewed left because here would be my ladder and I would slide to the right. Most of the values are on this side, whereas these values are pulling that mean to the left. Okay, again, I'm not going to draw it for you, but I think you would know most of the values are going to be on the left side, and then there's going to be some pulled to the right, and again, symmetrical. And you can fill in the histogram. It's going to be very similar. All right, so we talked about the shape of the distribution today: skewed left, skewed right, symmetrical, looking at all of the graphical representations, as well as looking at the relationship between the mean and the median.